Alrighty, and we are live. Hey everybody, and welcome back to another episode of Weekly Supervised. This is episode 3 of season 1, and today we have here Amber, myself. We have here a very good and old friend of mine, Mr. Bahman Ghandchi. We know each other for almost 13 years now. And I don't know, Bahman, how often do we keep in touch? Is it once every year, or how does it work? Exactly. So yeah, we've been in touch after we started doing a master's program in the same university, and I asked Bahman to come and talk to us about a few things. So a little bit about his research, and also a little bit about his work on the data science side. So a majority of our audience members, Bahman, just so you know, are data scientists and machine learning engineers. So with that being said, I just want to let everybody know a little bit about the logistics. If you see me going from this side of the camera to the other side, is because I'm monitoring different pages. So if you have questions for us, or basically for our guest, you could either put it in the live chat on our YouTube page, or if you'd like, you can join our Slack channel. There's also a channel over there for you to ask your questions. We're also going to be sharing some resources after this meeting or meetup, whatever you want to call it. So I really encourage you to join our Slack channel and be a member over there too. So with that being said, I will hand it off to you, Amber, to get us started.
For being here today. So excited. Thank you for joining Armand and I. And we're really excited to get to know you, and also just, get a brief background of your experience. So I guess to start with, would you mind just giving us a quick introduction of yourself and your work and your expertise? How did you kind of get to where you are today?
Yeah, sure. So, hello, and thank you for inviting me. I'm Baron Arman, and hello to your audience, who I have no idea about how many they are. Okay, my name is Bahman Ghandchi. I am originally. Can you hear me? Can you hear me?
We can hear you, yes. And seems like it's getting resolved. So I will check with Nishank just to make sure that he can hear you, because he put a comment. But yeah, let's continue, because it's good on our end.
Okay, cool. So, my name is Bahman Ghandchi. I live in Estonia. I came to Estonia to do my PhD in computer science. My background is mathematics. I got my bachelor's and master's in mathematics. And my main field of research in PhD is quantum computing. But I've done lots of stuff that are related to data science, like research, development, do some startup stuff that are totally related to data science. So, as I said, my main field is quantum computing, but not from physics side or engineering side. It's exactly from computer science side, which makes it a little bit what I do close to machine learning and data science. As an example, what we do is theoretically analyze the functions that come out of these quantum computers and writes codes for these computers, and try to experiment with it, try to do some quantum machine learning, quantum neural network stuff with it. So pretty close to data science, but not exactly. But that's for like another session. Today we are here to talk about Julia. Do you have any questions, or should I start? How should we go?
I actually wanted to encourage you to also let us know a little bit about your startup journey as well before we jump into Julia. So what exactly is the startup doing?
Okay, cool. So yeah, I started a company with a few of my friends and my supervisor, and the field of this company is quantum computing. It's actually a deep tech startup. It's not like we could sell our software to like 10,000 customers and get rich. Either we become like millionaires with it or nothing. So there's no middle point in between. So basically, right now, what we have in mind is to create some uh, middleware. Let's put it this way, because it's hard to explain the science behind it. But let's put it this way: we are trying to develop some middleware, which is mostly mathematical software needed in other industries that are gonna use quantum computers first. Like, for example, pharmaceutical companies, they need some quantum chemistry research. In their research and usage of these quantum computers, they need certain kind of optimizers and stuff that is not still available. And we have some ideas to develop a really cool, out of this world application with our knowledge to be the first one to show the quantum advantage. But who knows? Maybe we will be successful. Yeah, this is my startup journey. Arman, any
Awesome.
question?
Yeah, thank you so much for sharing that, and I really appreciate that. I think your startup is actually really cool. I was looking at it before this meeting, and I think the research focus is just, yeah, it's amazing. So thanks for sharing that earlier as well. So kind of now
Thank you
moving
very
a
much.
little bit into your experience with Julia, and I think why everybody was really excited and like waiting for this today. So in terms of your
For sure.
Julia journey, so why did you start coding in Julia? Why do you use Julia? And when did you start thinking that you should fork from like C++, Python, and Scala?
Yeah, so my journey with Julia started as a purely academic affair. We started using Julia in our courses where we teach stuff like discrete mathematics, foundations of mathematics for computer science, and stuff like that. So it started for me as a purely academic thing. But little by little, we saw the potential Julia has. We're gonna show the potential shortly, but to just put it short, in my opinion, Julia is a uh, very powerful tool for someone who wants to do scientific computing, especially if you're interested to do lots of prototyping. Like, you have lots of ideas, you want to implement your ideas, but like your main program is in C. It should be so fast, but implementing a mathematical idea in C and making sure it works perfectly, it's so hard. But doing it in a more expressive language like Julia or Python is so easy. But there was this missing link here that links this easiness of languages like Python and the speed that C offers. I think Julia offers that. There is this. It sits in this middle point. It has the ease of use of Python and it has the speed of C. So I think it's perfect for people who are mostly coming from scientific background and interested in prototyping their ideas. Even in production, the language is so robust and fast. It can easily be integrated into your C code base, and I think um, it's just logical to think that in the coming years, Julia community will grow much bigger than today, and use cases and applications will be much broader.
This is great. So I actually also wanted to mention something. I don't know how many people who are active Python developers or Python users know about this, but I mean, using notebooks has become part of our daily lives. Rapid application development in notebooks, and obviously Project Jupyter is one of the biggest, pioneers of that. But I don't know how many people actually do know this, that Jupyter actually stands for Julia, Python, and R.
Yes.
Yeah, so if you go and take a look at, I think the project initially was called Galileo, if I'm not wrong, but everybody talks about Jupyter and Jupyter notebooks, but that actually stands for Julia, Python, and R. So it's something that I always try to mention it in every meetup that I go and I talk about Python or something like that. You mentioned something, Bahman. So I actually, before asking my main question, I wanted to ask you a follow-up question. So you mentioned that this thing could grow, and you probably have seen a lot of use cases here. Who do you think can right now, and when I say who, not specific people, but have you seen this being used mainly in universities or startup companies, and eventually who do you think this Julia programming language can win in terms of basically having them move from, let's say, the likes of Java or C++ or even Python? Are there any specific organizations that you have in mind?
Uh, well, any government or organization, or I don't know, any institute, they can think about moving towards Julia, but the point is we have to focus on the main advantage of Julia. So in my view, the main advantage is that it connects the mindset of a scientist to a developer. Like we're gonna show it in a few minutes. Sometimes when I code Julia, it for me it feels like writing math, but in fact we are writing like proper computer code. But the syntax can be so close that I think it links and connects scientists to programming more and more. I think that's the main advantage, that at some point it will gain like lots of momentum in near future.
Yeah, and so you almost answered my next question briefly, but it seems like I've heard about this basically exact same answer from statisticians when they talk about R, and from computer engineers when they talk about Python. So it seems like it's a full package. So if you are a mathematician, then Julia is really good for you because it allows you to abstract out. And then if you are a statistician, then R is a perfect fit for you. And then similarly, Python or even Python for you if you are a computer programmer. But tell us a little bit about the main features of Julia. How does this change the life of a data scientist or a machine learning engineer easier? Like, is there any specific category of features that, now that you have been using this for a while, in retrospect, you look back at the times of writing C++ or Python code and say, hey, I wish I knew about this Julia thing like 5 years ago?
Yeah. So I think a good answer to this question is, in my view, speed. So even your inefficient code in Julia can be faster than the similar code in Python. That's the main difference. I mean, for sure, in Python, if you use really professional packages like NumPy, you have a really good speed up. But what is NumPy? NumPy is actually a bunch of C functions that's like behind the scenes Python is calling. But if you write like purely Python, your code will be like awfully slow. This is like one way Julia is so different from Python. Even if you try to code it in the worst way possible, the result will be better. Even if you try, your results cannot be that bad. So that's, I think, one way it can change stuff a little bit, because there is this problem in, I think, data science community that like many people in data science community are not actually computer programmers or mathematicians. So sometimes they come from like, different backgrounds. They get the idea. They understand what are like the main algorithms, what are the main methods to analyze and reason about data, but they miss lots of small details. So I think something like Julia will cover that part. I mean, like for someone who comes from, I don't know, some literature or something. I mean, maybe they're interested to do research on some text or stuff. I mean, probably they are not. I mean, for them, it's not important what type of array to use, how to just pack their data. This is something not important for them. For them, it's just important to know that their data is like arranged in something that looks like an array. That's enough for them, and I think it should be okay for them. And we shouldn't require people from different backgrounds to know as much as a computer engineer or a scientist. I think like this way, Julia can be useful. It can be helpful to many people.
Yeah, thank you so much for sharing that. And I, just wanted to echo your point. Totally agree with that from like personal experience. So I come from like a heavy humanities background, and definitely it took me a while to even understand like efficiency and that whole like aspect of like coding and data science and computer science. I think that's actually an awesome segue to our next question. So one of the things you mentioned earlier was even if you write like the slowest code in Julia, it'll still run faster than in Python. So do you have, any examples or potentially like a demo that could showcase like the speed difference or any like demo that you want to show us so how we can use Julia to wrap like C++ or Python code?
Yeah, I suggest we dive into Julia and let's see what happens. I'm gonna share one window with you.
Awesome.
So do you see this terminal?
Yes, I can see it. Thank you.
Okay. Okay, so this is Julia. And if you're familiar with Python, you are just one evening away from learning how to use Julia. But that's only just the first step, because in my opinion, there are like three levels of learning Julia. Learning to use Julia, that will just take an evening if you're familiar with Python. Learning to develop with Julia, that will take a while to understand everything in Julia. And the third level is, in my opinion, learn to embed and extend Julia with C. That's like the most sophisticated thing you can do with Julia, which like, takes your code and project to the next level. And of course, there is this other next level, which we won't talk about, that is developing Julia itself in C language. That's like what professional developers, Julia maintainers do right now. But we're not gonna go that deep. So why I like Julia? Simply just look at this. Uh, are you familiar with LaTeX? I type pi, hit tab, I have pi. Enter, I have pi. See? As beautiful as this. And just simply like this. 2 pi, it does the multiplication for you. This is something you don't see in other languages. I mean, it's not valid like in Python, it's not valid. Yeah, and this will help you to write code that looks pretty much like the math you write. Like, I'm gonna show you something here. Let's do this. And So just look at this piece of code. I mean, we are using LaTeX code, the language you use to write up your papers. You're exactly using the same symbols here, and you can use it in all your scripts and all your code, and it still works everywhere. So this was the first thing that sounds so interesting for me, and uh, I got so interested in learning Julia. But let's move a little bit further. I'm gonna show you some. I'm on my laptop, not a very um, powerful computer, but let's see what. Okay, a random matrix. Another random matrix, and simply if you do this code in Python, it will be awfully slow. You have to use different packages like NumPy, like SciPy to do this stuff for you. But this stuff are like built in Julia. So even if you try to be inefficient, your code is probably more efficient than the other languages. That's how Julia is different from the Python, and is in terms of speed is more like C. But we have talked a lot about C. Why this is important? I think it's the main important feature, at least for me, because when you have your C code base and you want to experiment with it with Julia, it's so easy to go back and forth from Julia, from and to Julia to C. Like managing memory from Julia and from C without any overhead, it's possible. I'm going to show you right now. You have an array that comes from C, you can manage the array in Julia, and vice versa. You start something in Julia, you just pass the pointer to C, you do something in C, and the pointer is still intact. The array maybe have changed based on your C code, and you get the result back in Julia. We're gonna see that, and that's why it makes it so interesting for someone who wants to do scientific programming. So I'm gonna stop this sharing and share my VS Code with you. Okay, do you see my VS Code?
Yes, we can see it. Thank you.
Okay, cool. So, what you're
Bahman,
gonna do
can you zoom in a little bit, just to make it a bit bigger? Thank you.
Is it better now? Is it better now?
Yes. Yeah. I keep forgetting that if you are presenting, you're not seeing our faces. Yes, it is.
Okay. What we're gonna do here today is so simple and messy. I mean, in fact, we're not even scratching the surface of what Julia is capable of. We are just doing the most basic thing that Julia can do with C. So what I have here is like a bunch of C functions, as simple as this in a C .c file. And what I do is that I compile it to get with this command gcc minus shared minus o lib test o minus fpic test.c. So this simply creates this lib.so for me, this one. And so I'm not gonna explain how C compilation works, but simply this is the shared library containing the compiled version of the functions, these simple functions we have here. And let's go back here to our Julia. So in Julia, using the C function, it will be as simple as this. So I'm gonna just open this shared library like this and simply call the C functions with a function, a built-in function of Julia, C call. So I'm gonna run it and we're gonna discuss the result. So one by one, so first of all, this is the result, but let's see what do we have. So the first line is 6. So let's go back here. So the first function we have from C is just prints one line, hello from C. And the function is called G. Okay, remember this G. Now we go back here. So look at this line. As simple as this. C call, as intuitive as it can be. C call a C function. C call, the symbol for that function name, the return type, which will be C void in the Julia side, means as it is as intuitive as it can be. C void. Let's go back. C G, the return type of G is void. So the return type is void. It doesn't have any argument type, and the arguments are empty. So it just calls the function G, and the result is written here. And now let's look at this one, the function working C. So what is working C? Working C calls the function F. Now let's look at F. What is F? Simply just an int function, gets an int, returns the same int plus 2. Just as simple as this. Now look at this line. What we do, we just call the works in C function with argument 4, and what it types is 6, exactly what we need. But so this still is not that much interesting, but with these two it becomes, I think, more interesting. Without any overhead, what happens here is that we create arrays in Julia, manipulating C, and again use in Julia, and also the other way around. We create some array in C and then use in Julia. So the first one, get array from C. What does it do? Calls the function H. Let's go back here. So here I have a very simple C function. It returns the pointer to an array, and simply it will be an int array of size of the argument it gets, and simply just fills it with numbers decreasingly. It starts from this first number and decreasing down. So, and then it returns the pointer. Again, we go back here. Get array from C, it C calls and returns the pointer. Then we just wrap a Julia wrapper around the memory that is owned by C. And then here, you see, we have the array we were expecting. So this is nice because there is no copying of data, there won't be any duplicates, and you're accessing actually the exact memory that C created and is using. So it's kind of shared between C and Julia. And also with the same logic, now we have this one. What we do is we are doing the reverse thing. We are starting something in Julia. This is like my array. And first I print this array. This array is this one, still 1, 2, 3, 4. And then I call this function manipulate array in C. What it does, it simply passes the pointer, the Julia pointer of the array to my C function. Let's go back and see my C function, L, function L. What it does, it's a silly function. Just gets an array, changes the first element to 22. We go back, look at it, so simple. We are just passing the pointer to a function in C, and again we are printing the Julia array. See, this is still this variable, and if you look at here, it is changed. So this is like the simplest way one could start explaining what Julia is capable of. I'm again saying we're not even scratching the surface of what Julia is capable of, because there are like lots of sophisticated packages where you can automate the build process for your really big C projects, and this is like just having one step as comparing to like a 10-hour flight. This is nothing compared to what Julia is capable of. But it's a good start. It's a good start for people who are not familiar with Julia. And yeah, like there's this other thing that I wanted to mention. I should have said it earlier, but now it's a good time even now. Okay, so let's look at this. There's one thing that I also really like about Julia, and that is actually one thing that I disliked about Python. I mean, I have developed Python for like so many years, but still sometimes I get confused about the way I have to install stuff and just manage my packages. At sometimes it gets so confusing. Still, it gets so confusing for me. But in Julia, I think the process is so simple, just very simple. Julia has this package mode by typing this character. When you type this character, not with this space. When you type this character, you go to the package mode, and installing something in Julia is as simple as add like plots, something as simple as this. If you want to remove it, then remove it. The process is very simple, very intuitive. There are no changes right now because I've already installed plots, but you just get the idea. And this the package mode of Julia has lots of features, and we're not gonna talk about it, but like one thing that I really like about it, and it's so handy, is that let's say you want to develop something in Julia. So what we did today was not actually the professional way. Professional way is to generate some PG. Okay, what I did here is that, just look at here. It created this folder for me with project Tomo and SRC and one template Julia file. This is the correct professional way of developing your Julia code. And this way has a very nice advantage. What you put in your packages will actually be pre-compiled. So the code you write modules and use later will be even faster as compared to just writing it here in just one simple script and run it from the command line from like Julia space your script.jl. Yeah, and the process, and I'm gonna just tell Julia that I'm developing this package. Okay, now I told Julia that I'm developing this package and simply say using some PPG. Now I'm using this package that I created and say this is the template function that I have here. But this is the professional way. If you want to do something serious, you have to put everything inside a module inside the package. And actually, this whole folder will be like your Git repository, and you put it somewhere, you host it somewhere in a Git repository online, and just give people the address to that repository. So I develop something, I give you the address for you installing it will be as simple as add uh, URL to your repo, and then you're done. You can install like your others code simply in your Julia installation. So this is like another thing that I really like about Julia. Everything I think might be so simplified. I at least I have not gotten confused like I had the experience with Python.
Yeah, thank you.
So any questions?
Yeah, I just wanted to, kind of like echo what you mentioned. I really love the features that you mentioned earlier, how it integrates with so many things like latex syntax and also just how you can wrap Julia code and, wrap other code like C and vice versa. Yeah, thank you for sharing that. So we actually have, before moving on to the next part, we have a few questions on our YouTube live. So thank you guys for asking questions. So our first question is from Vince Navida. So do you think that Julia is a good first language for someone who wants to get into data science?
Uh, it's hard to say. Um, I have to be honest and say no because we have to be realistic. Julia has been awesome for me because I already knew Python and like the market size for Python is obviously much bigger than Julia. Julia is nice. I think at the moment Julia is nice if you already know what you're doing. But you need something extra to speed up your process. But as something standalone that you learn and only learn that one to get into the job market, that's very tricky. I hope that happens in future, but to be realistic, I have to say no. It's not a good first line. I mean, certainly it's really nice to learn. It's fun. It's easy to learn. In that sense, it's a good language to learn. But don't have the expectation of like learning Julia over the weekend and expect having a job next week. No, that will not happen.
Yeah, thanks. I think that's great advice and definitely really good to be realistic. So, yeah, we have another question from Nishan Kadar. So they mentioned, like in Python, we have virtual environments to isolate these packages that you mentioned. What are the
Yes.
available options in Julia, and is there anything I can implement?
Yes. You can have the same functionality of environments in Julia, and yes, I mean the answer is positive. I did not prepare any demo for that, but yeah, actually, this is again one other thing that I was more okay with Julia than Python. This managing different environments and just locating locally the packages you have installed and just changing them, just managing what you have, what packages do you have, and where are they installed. At least for me, it was more clear. In Python, I always get confused. But I'm not saying it's better than Python. I That's something I never answered. That's actually, I think, a bad question. No language is better than the other. Every language is good for its purposes. So that's a silly question. in my opinion. But for me, this has been one of the advantages of Julia.
I also wanted to. So you kind of answered one of my biggest questions as you started looking into the packages. So thank you for that. It just to give a little bit of a kind of an icebreaker and a fun, so to speak, mode into this whole very technical conversation. It really makes my heart warm that I have a folder in your documents folder, so that's really nice of you.
Ah.
But I hope you don't delete it right after this call. But so this is really nice. It actually seems like to me that Julia was developed exactly for the type of lazy developers like myself, because I always also had the same problem of going from one virtual environment to another, trying to develop different things. And now I'm looking at this package, so to speak, functionality. This is brilliant. The only thing that I wanted to add to this, you kind of did, which is connecting this to Git and using this
Yeah,
basically to your benefit. So
yeah.
this is great. Do you have that experience yourself? Like, have you contributed to something, in terms of a package that other people, let's say in your research group, are using these days?
Yes, there are actually like a few packages we have developed so far that are publicly available, but they are mostly in the field of quantum computing. So one thing we did was that like the quantum computing scene is like so crowded in Python, so we decided to contribute in Julia. That's also like one thing that you have to take into account, because the Python scene is so crowded. Maybe in another language you can have a better contribution. That's what we did. So like my first Julia package was kind of a big Julia wrapper plus lots of functionality and extra features for a quantum simulator that's written in C. So that was our like first package in Julia. Then on top of that, right now we are developing a simulator for a certain type of quantum computers called the ion trap architecture that is coming up in a few weeks, and we hope to present it in the next JuliaCon in July this year. Yeah, and besides that, there's also this other package I'm right now developing for the mentorship program of the Quantum Open Source Foundation. It's a quantum optimal control package that I'm developing in Julia. That's also a work in progress.
These are a lot of great achievements. Thank you for sharing these with us. We have almost, I think, 14, 15 minutes. So Amber, I'll let you take us to the next question, just to be cognizant of time on everybody's front.
For sure, yeah. So thank you. So you told us a lot about kind of what you built with Julia and your experience with Julia, and also just like the cool things that you can do with it, as you've shown earlier in the demo. I know you mentioned earlier that maybe it might not be the best first language when you're learning data science, but what types of work is Julia best for? Do you think it's really good for exploration, data engineering, full stack app building? Like, if you could select a few, like, where do you think you would choose to use Julia over other languages?
So the first choice for me is education. So we are using Julia in like all of our courses right now. It's a very handy language. Also, even it has its own Jupyter-like environment called Pluto, which has like kind of some nice features on top of what Jupyter can offer you, some specific things related to Julia. So basically, the first use case, in my view, is education right now. It's really good in for any engineering and computer science and mathematics students learn and just speed up their learning process. Um, in terms of uh, data science, well, it is possible. Certainly, it is possible to do data science. But again, I think doing scientific programming and prototyping with Julia is my preferred use case for Julia. It's not that it's not possible to do data science. I mean, there are lots of packages you can do data analysis, data visualization with it, but just realizing your scientific ideas with Julia, I think, is so much easier compared to other languages. At least that has been like my experience. So to summarize the answer, the first use case is education, the second use case is scientific prototyping, the third will be data science, machine learning, and anything you may think.
Great. So um, this is great. So the other question that I also wanted to ask you, and I think now is the right time for it. So you mentioned things such as JuliaCon or even I don't know, like Julia Computing as a body or an organizer. But can you tell us a little bit more about the community? So does Julia also has a vibrant community, maybe not as vibrant as Python, but something that is always, trying to contribute, specifically around the ideas of machine learning and data science. For instance, and this is probably not a good question to ask, but do you know if we have something such as scikit-learn in Julia? I know I've seen projects around Kafka, for instance, for data engineering that is always in progress. But do you think that we have something as mature as, let's say, the likes of scikit-learn or maybe Spacey or anything like that in Julia? And if not, do you think is it because of the size of the community, or is it do you see that as an opportunity for somebody to start contributing more?
So first of all, the fact is, yeah, the number of tools and the level of the the level of sophistication of those tools is not that much comparable with Python. Like all big companies and big research institutes, they already have their packages in Python, so it's not fair to compare these two. And so there can be a number of reasons for that. I think the main one is that Julia is a relatively new language compared to Python. Python, if I remember correctly, is like 25 years old right now. Am I right? Yeah. So
I will
it's a
check the
relatively
exact age right now, but my guess is, yeah, a little bit less than 30 years.
okay. Okay, cool. Yeah, as I said, I think the main reason is that it's relatively new scene of programming languages, and mostly it has been used by scientists. It started in MIT, and like other scientists started using it. And yeah, I think it's not a good comparison. Certainly, Python is a more professional way right now, but I'm just trying to show the potential of Julia here. The potential is there, and I guess at some point it will gain the momentum as big as Python. Or who knows? I mean, because this technology they evolve. I mean, Julia has these like nice features. Maybe at some point we will have like newer version of Python which has the kind of similar capability. Like there are projects in Python that you like this thing Anaconda was doing this JIT stuff. I'm not that much familiar with it, but it's still possible to do it with Python, but the difference here is that you have to develop something on top of the core Python to gain those speed ups, but these stuff are already built into Julia. So I'm just trying to emphasize on the potential Julia has.
It's great, and I did check it, and I was by a small margin wrong. It's just a bit more than 30 years. So February 1991 was the
Mhm.
birth of Python, whereas Julia, I think, was, as you said, 2012 or 2013.
Mhm.
Yeah.
Yeah, it's relatively.
Yeah, exactly. I think that was the main question that I wanted to ask. If anybody wants to follow the news or wants to start learning, and I was going to also ask you to please share a few starting point learning basically journeys with us so that we could share it on our Slack. But if anybody wants to follow and get better visibility into Julia, what are your recommendations? Where should they start?
Um, so I think the best resource is the main Julia webpage, julialang.org. They have a really good documentation there and link to lots of courses and material. Also, I suggest you look into the JuliaCon, the previous versions and new version that will come in July. But yeah, start with Julia main webpage. It will give you lots of resources and it will point you to lots of different web pages that have lots of good material.
Awesome. Yeah, thank you so much. I actually have a quick follow-up question. So you mentioned earlier, you showed us a really awesome example of how to use Julia if you're just starting out. And you also talked about how you kind of use it in your research and also like all the other packages that you created. Do you have any, project or research paper that you use Julia for that you are particularly proud of or excited about? Anything that we should look up after this talk, basically, that you did in Julia?
Uh, well, I can't say I'm proud of. That's like too much, but the packages we created, I'm kind of I feel good about them. I feel good about what we did. Uh, but yeah, and in my research, well, I do lots of experiments with Julia to like try out the ideas I have, just check out if the idea is correct or not in like small examples. But we haven't done like heavy research using Julia yet. We have used like other stuff, like mainly machine learning, quantum computing software. But here's the thing. Actually, we thought about this, and one of the goals of this ongoing project that we have right now is to create a simulator in University of Tartu. The simulator is written in Julia, and the simulator itself is not the most important part, but it will be a project that quantum computer scientists can use in their research to like do their simulation, validate their hypothesis, and basically do their research with. So the goal of this project is to get to the point that one can use Julia in their quantum computing research.
All right, great. So again, just to be cognizant of everybody's time, I think we're almost at the end of the time that we have. So Bahman, I will remove your presentation from the meeting so that people could see everybody's face.
Okay.
Or if you want to do it yourself, that's brilliant. Great.
Nice.
So I wanted to also let everybody who's listening in know that probably at some point in the future, I don't know. So we have already fixed, I think, all the guests for season one, and then after that we have a long list for seasons two and three. But we got thumbs up from Bahman to come back, and we were probably going to have another session with him just talking about quantum computing. So we're going to take you on that word, Bahman, at some point in the next probably 6 to 12
No,
months.
by
to
then
get
I'm
back.
gonna, as I told you, by then I'm gonna talk about robots,
Yes. So
autonomous robots. That's the new thing I've started.
my hope is that by that point in time you are rich, and then you would be one of the sponsors of this show or podcast. But until that point in time, because we don't really have a real sponsor, so this is a shameless promotion for myself. So I have started also working with a few new friends on kind of a research group. So I think I mentioned it last week as well. There's no webpage or anything yet, but you can find us on LinkedIn if you go and try and find the logo on the top right hand corner. If I'm right, it's called Federate AI. We're trying to solve some of the biggest problems that researchers and developers in the field of machine learning engineering have these days. So if you are game for basically volunteering a few hours a week to working with people like myself, like Bahman or Amber, please take a look at that and get in touch with us as well. And then we are again also going to be back next week with another brilliant guest and another topic. Again, the event page on LinkedIn or our YouTube channel is the best place if you want to follow it. And I really hope that you could join us again next week, same time. Off to you, Bahman, if you have some closing remarks, and Amber, for you to close off this session.
Yeah, thank you for inviting me. It was a really interesting and nice session. I really enjoyed talking to you guys. Stay safe and hope to see you all soon.
Yeah, so again, thank you everyone for coming. Thank you, Bahman, for being a guest, and obviously, Arman, thank you for hosting. If you guys want to connect with us, as Arman said, you can chat with us on YouTube or join our Slack channel, and we also have a LinkedIn. So yeah, excited for next week, and I hope to see you all at 2:30 p.m. Eastern Time. Thank you.
Goodbye.